Okay. Hello, everyone. I'm Balázs Gerlei. I work at Outsoft. I'm working mainly on iOS and Android applications. My main focus is Android. I mainly develop native applications, but today I will talk about cross-platform solution. Cross-platform solutions are interesting, right? Let me ask, who is an Android developer? And who is an iOS developer? Okay, yes, Flutter works on both. So the title of my talk is Flutter, true cross-platform solution, or just a tool for prototyping. And the main question I would like to answer is that if you, whether you can use it for production applications or not. So first, what is Flutter? Who heard about Flutter? Quite a few. So it's according to Google, Flutter is a new mobile app SDK to help developers and designers build mobile applications for iOS and Android. It's open source, developed by Google. It's unfortunately still in alpha, and aims to enable shared code base, shared designs, and actually shared teams, developer teams, working on the same project. It provides fast and Flutter apps are fast and performant, and at the same time highly customizable. You write your applications in Dart. That's the only language you use, both for UI and the code. I will show you later. You can check the official documentation at flutter.io. So what's Dart? Dart is a new language, also developed by Google. It's used internally for a long time. It's battle tested, but unfortunately there are not a lot of outside projects with that. It's also open source, as I said, very similar syntax to Java, JavaScript, and maybe a little bit to Kotlin. It has an optional but strong type system. It's still developed fast, so some changes are to be done. It has a fast generational garbage collection. As I already mentioned, it is very, very fast and performant. And it has a tree-shaking compiler, which basically removes the dead code, so it's resulting in very small binaries. It's heavily used mainly in web development. So what's the motivation behind developing Flutter? Well, developing for mobile is hard. I think this is not a new thing. Platform diversity and fragmentation, especially on Android, but we recently heard about the new iOS devices. You know, now we have the 6S, the 7, the SE, the iPhone 10X, no, sorry, it's 10. So the iPhone 10, so different screen sizes, resolutions. You have to aim for different devices. The market is basically a two-horse race between Android and iOS. You maybe heard that Windows Phone is now officially dead. So, but using and managing two separate teams are still not an easy job. At my job, as I said, I develop for both Android and iOS. I'm often a bridge between the two development teams, but it's not an easy task to manage them, and especially when new features come in, the customer often wants them to release at the same time for the two platforms. Well, you've heard it before, write once, run everywhere. That's very enticing promise, but basically none of the existing solutions can truly deliver. And you should be able to trust that your users will see the same thing that you see on your development devices. And as Android and iOS developers, we know that that's not always the case. So what's Flutter's solution to these problems? Well, as I said, it's a cross-platform SDK, but contrary to most cross-platform SDKs, it doesn't have an overhead of slow bridges between the native and the cross-platform environment. All the code is compiled to native code, so this gives a fast performance. Flutter takes a different approach than most other platform frameworks. It basically renders the whole UI, so it takes over the whole screen, does every rendering. There are no native views, all views called widgets in the Flutter world, and it's all rendered by the framework. So this means that your applications will look the same on every platform versions, every OEM versions, every Android and iOS versions. Even OEM customizations won't affect your code. And one of the main goals of the Flutter developers was to provide a very productive development environment. We'll see in a bit how it is achieved. Well, layout rendering, as I said, is done entirely by the framework. It can be fast because, unlike most other platforms, which either join layout and painting or do multipass layout, Flutter has a one-pass and separated layout and painting. It invalidates subtrees and not rectangles because Flutter developers found that the old way of invalidating rectangles on the screen works well on desktop, but not very well on mobile. And it uses a very simple constraint model, basically just minimum and maximum widths and heights. So none of the iOS complicated constraint model, but something similar. And as I said, it invalidates subtrees, not rectangles. So Flutter UI is entirely code. There is no declarative languages describing your UI. You write it as the rest of the application. Of course, it is good to separate it to a separate class. Flutter favors composition over inheritance. It's almost everything you see on the screen is a widget, is some kind of view, even padding. So if you apply a padding to another widget in Flutter, you embed it inside a padding class. Flutter has two kinds of widgets. The first is a stateless widgets, which are completely immutable views. A great example is a simple text showing on a screen, but an entire screen which shows a static data can be a stateless immutable view. And there are stateful widgets which are mutable. For example, a list you retrieve from the network. Here's an example of a widget. You can see that it extends a stateless widget, so it doesn't contain state. It only has a build method which returns the widget it needs to be displayed. In this case, it's a column which does what it says, lays out children vertically below each other. In this example, we lay out text and the center, which contained in the children property as a widget list. So there's a one displayed on the screen, and below it there's a center, and inside it, hello world. Yes, very creative. So the center widget, similarly to the padding, does every laying out its child at the center, as the name says. And here comes what I already mentioned, the fast and productive development cycle. Hot reload is very similar to the Android instant run feature, but it works on iOS too. And it's very, very performant, and I haven't encountered any bugs with it. It preserves state, so basically the heap and the stack. So it's very easy to develop screens which are hidden deep in the navigation hierarchy. You don't need to navigate there after changing the code. It just hits hot reload and reloads the application. And it is really fast and reliable, as I said it. You should not have to wait for compiling, rebuilding, and running the application. That's the aim. So the organizer said that one of the presenters can't come, so I put a little demonstration in the presentation, what can go wrong. When creating applications, we aim to do a good, clean architecture. Basically, this diagram shows how I think that a good architecture looks like on Android. I use some RX here, as I will show later, but basically the interaction between the different parts is one direction using RX streams, but you don't have to really know RX, just that the data flows from here to there, and the architecture is separated to three different parts: the presentation, domain, and the data layer. The data layer knows everything about data, and every caller of it just sees an interface, doesn't need to know where the data comes from, whether it's a network, a database, or something else. All the business logic goes to the domain with use cases or interactors, if you like, and the presentation layer uses MVP, for example, to display the data. Also, the separation of these layers are good because it follows the dependency rule. So every layer is only dependent in the one inside it. So I will show you the application. It's a very basic example. You develop applications in IntelliJ. There is a plugin for Dart, and you have to download the Dart SDK as well. But after that, you just run your applications on Android and iOS emulators. With this example, which I originally created for an article, which, if the stars align well, will be published soon, demonstrates whether you can use Dart to create this kind of clean architecture. So the app is starting. Okay, well, this is just a basic list of the New York Times most popular applications, APIs list of new articles or most popular articles. Well, there's a lot of settings here, maybe. Okay, maybe some UFNR. That would cheer us up, yeah. So it's basically just a list, and when you click on one of the items, it shows the details. Very basic application, but it's developed using the architecture I've shown you and with Dart. You maybe found this little badge here. It says slow mode. It means that when you debug, Flutter applications running in a debug state, which differs from the real release and doesn't comply to bytecode. It's slower, as the name suggests, but you can debug it. So very basic application, what I would like to show you is how hot reload works. For example, in this detail view, if I put it here. Is it visible? So basically, as you can see, this is a widget. As I showed you earlier, in the build method, we returns what needs to be displayed inside it. And for example, here the image is loaded from the network. Flutter does this automatically, which you would use a library otherwise in most platforms. So it's loaded asynchronously, gets from the network. And it's only this code, image.network, the URL, the height, and it loads it automatically asynchronously. So if I'd like to add another widget, it will be a stateless widget, so it doesn't have state, it's immutable. And we simply implement the build method and return the widget to be displayed. Well, it doesn't want to work. Okay. That's interesting. Then I won't show you that. But I can still show you the changing ops. So changing the color of the toolbar. It's a bit basic, but as I said, I didn't prepare this example for the talk. Really, just as you can see, when you change something, for example, the color, it can be reloaded with the hot reload feature. And this one should be working with and adding a new widget, as I would have liked to show you. No worries, go back to the slides. So, does it used in production? Well, there's one example, the Hamilton application. I don't know if you heard about it. It's a very popular musical in the United States, and the official application of it is written in Flutter. It has an almost fully custom design, and almost doesn't use really platform-specific views or widgets. It has a very big user base, a lot of installs and daily actives, as you can see in the slides. And the UI of it is entirely custom, but looks the same on both platforms. It has an interesting lottery feature where you can win tickets to the musical, very cheap tickets. It's used by a lot of customers, and it remains performant. So, can it be used in production? I mean, I talked about one application, but there are really not other applications on the store right now. I mean, the Hamilton application is featured on both platforms, but Google only uses it internally in some of its projects. So, well, maybe it can be used. It's in a very early stage. It's hard to tell yet, but it's promising for applications that either use pure material design implementations or very custom designs, as the Hamilton application. It works quite well. But applications with deep system integrations, it can be hard to use. For example, things that you expect from the Android or iOS SDK, like checking the network connectivity, it can only be done with a library, a package in Flutter World. But other things, like getting a network image, as I showed, is built in. So it's kind of a mixed bag. I would say that promotional type apps like the Hamilton, or for some events like a conference, it can be a great choice. But I think it's not yet suited for most complex applications. I didn't experience a lot of bugs using it, but still there are some. And although the community is very helping, it's a little bit time sink to explore the API in itself, because documentation is still lacking in some places, but it's improving. As I said, it's all only in alpha version. Its advantages: it's the most complete material design implementation. So almost everything which is described in the material design specs is available as Flutter widgets, but sometimes you can feel boxed in. As I said, all renderings is done by Flutter, so the apps looks the same on all platform versions, and hot reload works really well, and development cycles are fast. The static analysis tools are also very good, built into the IntelliJ IDE with the Flutter plugin, and it has an enthusiastic community. But it has disadvantages. I would say that avoid being the biggest user of some library, and at this time you can be the biggest user of some parts of this library. It's used by few, and you definitely have to learn a new language, which is very similar to Java, but still a new language. And still under active development, iOS developers using Swift can relate. And it's very easy to mix in the UI code with the logic of the application. Of course, you can use MVP or MVVM architecture to mitigate this problem, but still, sometimes it's easier to write a UI in a declarative way, like on Android. And sometimes you can feel very boxed in with the built-in widget system. They say it's highly customizable, which is true in some parts, but in others, there are some private APIs which you cannot override, and writing a whole new view so writing a whole new view can be quite hard. And the built-in views are mostly inspired by material design. There are some implementations for the iOS design, but not many. And there is not a lot of available libraries, and some of it are the basic ones. For example, to check the network state, or some very, very basic SQLite implementations. There are no more advanced persistence libraries, for example, like RAM or something else. There is only 2 SQLite implementations now. And these libraries are not always suited well for both platforms. So I would like to thank you and answer some questions if you have. Okay, then no questions. Thank you very much. And I will show you some links. The slides will be uploaded so you can follow them. And there are some great presentations about Flutter. Thank you.